Welcome back. My name is Satyajeet Sahu and we are in IIT Kanpur previous year series. Okay, so previous year question series. But I will be not only solving the questions from IIT Kanpur, but I will be solving much more questions. Okay, so we'll solve the questions which are asked in IIT Kanpur and also other years. So let us welcome all the participants. Okay, the participants are Ms. Juhi, Prithvi, Suranjit, Beast Incarnate, Samriddhi, Hanya, Anu, Rajasri, Saurabhsi, Mukul and Bijit. So a short introduction about myself. My name is Satyajeet Sahu and I have 10 plus year experience in the field of your GATE and ESC. Okay. My achievements are I have done my BTech from IIT Kharagpur and also MTech from IIT Kharagpur. I have been selected into many PSUs through GATE and I have taught in more than 15 states. So more participants are coming. So welcome Aptab, Rahul, Vivek, Aman, okay, Deepika, TTV Logs. Okay, so many participants. Hope you all are excited. Hello Siddharth. Let us start the class. So we'll start the class with what? Fluid kinematics. We'll start the class with fluid kinematics. Hope you're all excited about the class, fluid kinematics. Okay, so let us start with what? Fluid kinematics. Okay. Hello Siddharth, hello Suranjit. Okay, welcome to all. Right? Welcome to all. Okay. So first of all, we'll start with what? Continuity equation. Is my sound clear? Is my sound clear? Is my sound clear to all? I have a small suggestion. Please mention in the comment section. Okay. The sound is clear? Okay. Very good. All clear. Let us start the class. So first we'll start with continuity equation. So first we'll start with what? Continuity equation. So we'll write first the generalized equation of your continuity equation. Then we'll go into specific cases. So what is the generalized equation? It is the differentiation of your density with respect to time plus the differentiation of rho into u with respect to x, okay, then rho into your v with respect to y, and then differentiation of rho into w with respect to z, okay, and this is equal to 0. This is what the generalized continuity equation. Now suppose there is a fluid particle. So fluid particle will have a velocity, and velocity is a vector. So it will have three components, right? The three components will be u, v and w. And u will be in the x direction. So u I cap plus v j cap okay, Raju, your doubt I'll clear later. First let us focus on the class, okay? So v j cap and then w cap. This is what? This is your v vector. Now you might have heard or you have not heard. So in which month I stop taking all and division all. Okay, so please let us first focus on the class. Okay, then we will take this doubt at the end. Okay. Now you might have heard about the del operator. What is this del operator? If you have not heard, then I will tell. This is nothing but d of dx of I cap plus d of dy of j cap and then d of dz of k cap. Now see very interesting thing. If I multiply rho here, this will become what? Rho into u, then rho into v, and then rho into w, right? Now if I do this dot product, this is dot product of two vectors, yes? This is dot product of two vectors. You see, this is a vector, this is a vector. Now in dot product, we know that it is what? It is, suppose A dot B. It is what? Tell me. A, B, what? Sin theta or cos theta? A, B sin theta or cos theta? Tell me. It will be A, B sin theta or cos theta? Dot product. Yes, it is cos theta. It is cos theta. Now see, I, j and k will be perpendicular to each other. They are perpendicular unit vectors, I can say. Yes, they are perpendicular to each other. So when you are doing a dot product, I into I will give me what? 1, right? But I dot j will give me what? 0, na? Because cos 90 will be what? Cos 90 will be 0, right? So whenever I'm doing the dot product, what I will do? I will just take I and I, j and j, and k. Then I will get what? 1. So this will become what? Tell me. It will be d of dx of rho into u. You see? I of this and then I of this. Yes? Then j of this and j of this. So what I will get? I'll get d by dy of rho into v. Right? And then last, what I will get? D of rho into your W. Understood this formula? Everybody understood this formula how I got? Everybody understood this formula how I got? Yes? How I got? Everybody understood? Yes. So that means I can say this term is nothing but what? Tell me. This term is nothing but what? This term is nothing but this one, right? Yes, this term is nothing but this one, right? So now I can say that what is the continuity equation? It is the differentiation of the density with respect to time plus del operator dot product rho into velocity vector. This is equal to 0. Everybody understood how I transformed this continuity equation? How I transformed this continuity equation? Everybody understood? Okay. See, I'm not straightforward solving questions, because if I've not understood the basics, then how I will solve questions? Therefore, first I'm going through the basics and then we will see the previous year questions. It will be very exciting for all of you. Don't worry. Now you see. What is steady flow? If I say the flow is steady, steady flow means that rho, the density, is independent of time. Yes, it is independent of time. Yes, it is independent of time, or I can say your t. Okay, or t. So what will happen? Tell me. This will become 0 na if the flow is steady, because if it is independent, that means what? It is constant with respect to time, right? It is independent of time means what? It is constant with respect to time. I can say in that way, right? Okay, so I can say for your steady flow, what will be your continuity equation? It will be del operator acting on what? Rho into V. And this is equal to 0. This is equal to 0. This is for a steady flow. See, try to understand. I cannot write like this. Some people can think, we can take this rho outside. But that is wrong. Why I cannot take rho outside? See, rho, density, will be a function of what? It will be a function of space and time. Yes, it's a function of space and time. Space means what? X, Y, Z coordinates and the time t. So when I say it is steady, that means it became only independent of time. The rho is still a function of what? X, Y and Z. So I cannot take this rho term outside because it has not become entirely constant. Everybody understood this concept or not? Everybody understood this concept or not? Why I am not able to take this rho outside even if the flow is steady? Because the rho has only become independent of time, it is still a function of your space. So I cannot take this outside, okay? Now, if I say rho is constant, so difference you understood? Rho becoming independent of time doesn't mean that it is constant, right? It is only independent of time. So when I say rho is constant, that means what? That means now it has become independent of space and time both, right? And in that case, I can take the rho outside and this will be the equation. This will be the equation. del operator acting on V vector, this is equal to 0, right? The rho is what? Constant. And rho is constant means what? The flow become incompressible. The flow become what? Incompressible, because the density is constant. Now the rho is constant, so I can remove this and I can write on what? Del operator acting on V vector is equal to 0, right? So you see this particular equation, and as rightly pointed out by Rana Rajput, right? Here, this is applicable only for what? Incompressible flow. It's only applicable for what? Incompressible flow, because I cannot apply this in only steady flow. Why? Because in steady flow, it is independent of time. Yes, but in incompressible flow, it becomes independent of time and space both. It becomes constant. So I can write this equation. Yes, I can write this equation, right? See, I can write this for what? Steady incompressible flow, right? I can write this for what? Steady incompressible flow. See, if it is incompressible, then it is not only independent of space, it becomes independent of time also, right? But for only steady, I can write this equation, right? And for steady incompressible, I will write this equation. Understood the difference between these two equations? In objective examination, they will ask only which equation is applicable. Which equation is applicable? Okay. Now, let us come to this incompressible flow. So this is equal to 0. This is for what? This is for your incompressible flow. This is for your incompressible flow, right? What was this? This was what? d of dx I cap plus d of dy j cap, and this is d of dz k cap, right? And your velocity vector is what? u I cap plus v j cap plus w k cap, right? Right? So when I take this dot product, what I get? du by dx plus dv by dy plus dw by dz is equal to 0. So ladies and gentlemen, this is a very important equation. It is applicable for what? Incompressible flow. This is the continuity equation for what? Incompressible flow. Now hope everybody has understood the continuity equation for what? Incompressible flow. So time to solve some questions. So now time to solve some questions. Okay. So everybody is ready to solve questions now. Okay. So everybody is ready to solve questions now. Okay. So please write yes in the comment section. So we'll start solving questions. Okay. Chalo. Okay. Is the following a possible incompressible flow? Is the following a possible incompressible flow? So you see how to solve this? This is U, this is V, and this is W, right? Yes. So please check that du by dx plus dv by dy plus dw by dz is 0 or not. If it is 0, then it will become what? An incompressible flow. Please check and tell me. Please check and tell me. By the time I will have some water. Yes, incompressible. Not 0, you're getting not 0. How? Differentiate this 5x cube with respect to x will get how much? 15x square. Now differentiate this with respect to only y. So we'll get what? Minus 15x square. And then differentiate the last term. This is only t. So it become what? 0. So this get cancelled. I get 0. So yes, this is a possible case of what? Incompressible flow. Okay. Now the next question. Okay. The next question. What is the question? Now these are not previous year questions. These are questions by me. Then we'll come to previous year questions. Don't worry. You see it is what? U is given. Yes. We have to find out V. It's a 2D flow. 2D incompressible flow. So I can say in 2D flow, what I can say? du by dx plus dv by dy is equal to 0. See, in this case, what I will do? Tell me. You know this function, this, right? So du by dx will give me how much? it will give me 4y, right? Where differentiating with respect to only x. There partial differentiation, yes. So I'm differentiating with respect to only x. So I'll get 4y, right? See, first term is y square, so I get a 0 if differentiate with respect to x. Then 4xy differentiate with respect to your x will give 4y. So 4y plus dv by dy is equal to 0. So from here, dv by dy is equal to minus 4y. So what will be? What will be the v function? To find out v function, I will take what? dv is equal to minus 4y dy. I will do an integration, right? I will do an integration. So if you give me v, you give me how much? You give me minus 2y square. It will give me how much? Minus 2y square. Now you see, we are differentiating, we are integrating with respect to y. So the constant of integration will be a function of x, right? Right? See, we are integrating with respect to y. So the constant of integration will be a function of x, right? Now this is the v we are getting. Now they have given a boundary condition. What boundary condition they have given? The y component means what? The v is 0 at y is equal to 0. So put y is equal to 0 and v is equal to 0. That means what? This x function becomes what? This also becomes 0. So I can say the velocity v means what? The y component is minus 2y square. Understood this question, everyone? Understood this question, everyone? In the previous case, they have given the x, y, z component and asked, is it a possible case of incompressible flow? Here they have given the u component and they have given what? It is an incompressible flow. So applying the continuity equation and then using some of your common sense and your childhood knowledge of integration, and then you are solving this question. Let us go to the next question. Okay, some GATE questions now. GATE 2020. Now you might be telling, sir, we are solving IIT Kanpur series now. Why we are solving GATE 2020? Because in IIT Kanpur they have only asked 4-5 questions. Do you want to solve only 4-5 questions, or you want to solve entire range of questions? Please tell me. Do you want to solve only 2-3 questions, or you want to solve an entire range of questions? Obviously, you will want to solve entire range of questions, and therefore, we will solve a lot of questions. We will cover IIT Kanpur, we will cover IIT Kharagpur, we will cover IIT Guwahati, Delhi, Bombay, Chennai, everything. So please solve this question. Please solve this question. And it is incompressible flow. It is just, I have forgot to mention it is incompressible flow. Please solve this question. Let us see. B, you have to find out. Okay, somebody has found out the answer also. D, very good. Very good, D. Yes, D, very good. You see the last one. See, W is 3. So differentiation with respect to Z will be 0 only, na? Yes. And then I get this. So from here what I can say? I can say that your dV by dy is equal to what? 4x. Minus 4x. It is minus 4x. Now what I will do? So if I integrate with respect to, I'll integrate this with respect to what? Your y. So what I will get? I will get this as minus 4xy. So we have only one option now. We have only one option matching it. But still, see, we are integrating with respect to y. That means the next one will get a function of x and z na. The constant of integration will get a function of x and z na, because we are integrating with respect to y. Understood? The answer is what? D. So now you see, it is easy or difficult? It is easy. So solve the next question. Asked in 1995. Who all were not born in 1995? Who was born, who was not born? Please write in the comment section. Who was born, who was not born? Please write in the comment section. Who was born? Rahul, okay, not born. 97, not born. 97. So you see, born. You see. So from the time you were not born to the time you are born. Okay, it means now. Okay. That means I can say, you see, things have remained pretty much same. Yes. So you see, GATE 1995. Now solve this. What is given? Incompressible flow. Please solve this question. Let us see who solves this first. Incompressible flow. What is the value of this lambda? Please find out. Miss Deepika, Miss Survi, Mr. Siddharth, Mr. Aptab, Mr. Rahul, Mr. Bijit, Mr. Amir, Mr. Prithvi, all of you. Please solve. All these are GATE 2 mark questions, and you can see that you are able to solve with so much of ease, right? You are able to solve so much. We have found out the answer also, you see. We have found out the answer, right? You see, so easy questions. The questions are not easy, they are made easy. Okay. Others. Thus, it is incompressible flow, so du by dx, it's a 2D flow, plus dv by dy is equal to 0. Okay. Okay. 9 by y. Let us see. See, differentiate with respect to x. So, partial differentiation. So, lambda y square minus 2xy. Now, this differentiate this with respect to what? With respect to y. So, becomes what? Plus 2xy minus 3 by... Sorry. Aha, there is some printing mistake. I am extremely sorry. There is a printing mistake. Okay. Sorry, it is a printing mistake. So it's 3 by 4 into 4 y cube, right? So 4 get cancelled, and this is equal to 0. This get cancelled. So lambda, then I can say if I take lambda common, then lambda minus 3 y cube is equal to 0. And if it has to be 0, so if I say y is equal to 0 becomes trivial, so I can say the lambda is 3. Sorry for this mistake. It is what? Incompressible flow. Now, continuity equation comes from which principle? It comes from the principle of what? Conservation of mass, right? The continuity equation, I have not derived the equation. If you want to see the derivation of equation, I have done the derivation of the initial equation. You see, this initial equation which I wrote and then, concluded some things. Okay, the initial equation which I wrote and concluded some things, right? This equation, it comes from the mass conservation. I have derived this, okay, I have derived it, the mass rate flow and all. I cannot derive it here because if I derive it will take 45 minutes. So I don't want to waste your time. Okay, if you want to see the derivation, it is available in the BYJU'S Exam Prep app. You can go there, you can see in the fluid mechanics, in fluid kinematics, I have derived this continuity equation. Okay, now coming back to a question. You see this question was asked in 2006. This question was asked in 2006. So they have given a velocity vector. You see this is the u component, this is the v component, and this is the w component. And you see the density is a function of time. They're writing if the mass has to be conserved, then what is the value of lambda? Now how to solve this question? Okay. First of all, when they're writing mass to be conserved, and nothing is mentioned, is not incompressible flow. So I have to use the general equation. General equation is what? The differentiation of rho with respect to time plus the differentiation of rho u with respect to x plus differentiation of rho v with respect to y plus differentiation of rho w with respect to z is equal to 0. Right? So use this relationship, the original continuity equation, and solve this question and find out the value of lambda. Please find out this. GATE 2006 question. Hope you are enjoying this session where I am not solving only IIT Kanpur questions, I am solving everything. -8, very good. You see, this u, v and w are function of x, y, z. But rho is a function of only time. So when you're differentiating with respect to x, y, z, so rho will not matter, right? So I can take that rho outside. And I can write this as what? First, if I differentiate this rho, means this one with respect to time, what I will get? I'll get minus 2 rho naught e to the power minus 2t, right? If I differentiate this with respect to time, then I can take the rho outside. And then what I can do? I can differentiate u with respect to x. So it will become what? 5. Then v with respect to y, it will become again 5, right? And then w with respect to z, it will become what? Lambda. Yes or no? Yes or no? You see, 5, 5, lambda. Yes, and this is equal to 0. Now see, what is rho? This is rho, right? This is rho, right? So I can write down here rho, right? Yes. So if I take the rho common, so I'll get what? Minus 2 plus 5 plus lambda is equal to 0. So from here, lambda is how much I'm getting? I'm getting minus 8. Again, a very easy, straightforward 2-mark question. Yes, that's it. Now solve this question. This is a good question. So finally the IIT Kanpur question has arrived. So many of you are looking for IIT Kanpur. So the IIT Kanpur set a question in 2015, this question, okay. It's IIT Kanpur question. But before that we solved hell lot of questions, okay. So please solve this question. So the x component means what? This is your u, okay. Okay, and this is what? This is your rho. This is rho given, okay. Rho is a function of x here, which the following is a function of your y, okay. And then written steady flow. Please solve this. What I will do for steady flow, dou rho by dou t is 0. So I can use this rho u, yes, plus rho v, this equal to 0, right? I will use this equation, okay. Hey Rahul and Ami, don't talk among yourself. Please focus on the class. Especially Rahul, don't talk with other students. Focus on class, okay? And don't laugh. Focus on class, okay? Now you see, this was the equation for steady flow, right? Remember? You remember this was the equation for steady flow. Yes or no? Yes or no? If you remember, initially I gave this as the equation for steady flow. The rho term was inside. So if you multiply rho with your u, what you will get? This you will get as 1 by x into x square, right? And then differentiation of this. This will be how much, tell me? This will be how much, tell me? This will be 1, na? This will be 1, na? Yeah, this will be 1. So this is your 1 plus del of 1 by x of v, or I can say v by x. Okay, this is equal to 0, and I can say this becomes what? Minus 1. This becomes what? Minus 1. Then what I can write down? Then this I can write down as d of v by x is equal to minus dy. So now if you integrate this, what I will get? V by x is equal to minus y, and v will be what? Minus xy. Understood? Understood this question? Now you see there was difference, right? And therefore initially if you remember, initially I gave you a thorough explanation of the different forms of continuity equation, and hope that thing helped you in solving this question. So hope you enjoyed these numericals on continuity equation. Everybody enjoyed the numericals on continuity equation? Yes or no? Yes. So let us move on to something else. Let us go to acceleration, right? Let us go to something what? Acceleration of fluid particle, right? Now we know that velocity has components what? U, v and w in your x, y, z direction. Now the acceleration in x direction will be what? That will be, if I differentiate with respect to time only, it will be du by dt. Yes, du by dt. Now u is what? Dx by dt, right? Dx by dt. So this becomes what? double derivative of x with respect to time. If I'm taking only time into picture, then this will be what? This will be dv by dt, and velocity is y component is what? dy by dt, right? So this becomes what? Double derivative of y with respect to time. And then acceleration in z direction will be dw by dt, and obviously this will become what? D square z by dt. So this is one form. This is one form of finding out the accelerations. Okay, this is one form of finding the acceleration of a particle, fluid particle. Now see, there's another form also. What is that another form? Let us understand. What is that another form? Let us understand. You see, acceleration in x direction is what? Du by dt, right? Yes. Now you see, this u will be a function of what? It will be a function of x, y, z and time. Means basically space and time. Basically space and time. Very good. So now this thing I can write down as what? Partial derivative of u with respect to x. Then dx by dt. Yes, I can write like this. Then partial derivative of u with respect to y. Then what? dy by dt. Plus partial derivative of u with respect to z. Then dz by dt. And then your partial derivative of u with respect to time. Then dt by dt. Can I write like this? Can I write like this? Because this u was a function of x, y, z. So del u by del x, del u by del y, del u by del z, and then del u by del t. Understood this? Yes, understood this. Now what is this? This is u na. This is v na. This is w na. Yes. So I can say the acceleration in x component or x direction will be what? Your u into del u by del x plus v into del u by del y, right? Plus w into what? Your del u by del z, and then the last term, that is what? Del u by del t. This is 1, na? Del t by del t is 1, na? Everybody understood this equation or not? Everybody understood this equation or not? Yes, you have understood this equation, right? You have understood this equation. Now you see, this is known as what? The local or temporal component of your acceleration. Known as what? Local or temporal component of your acceleration. And this is known as what? The convective component of acceleration. What? Convective component of acceleration. Now how to remember this equation? Yes, we've understood the derivation and all. How to remember this equation? That is little tricky. So I'll give you a very easy trick. I give you a trick. I derived also. I will give you trick also. You see ax, ay, az. Okay. Now x means what? U na. X means what? U na. Yes, in x as in u. So you'll differentiate u with respect to x. You will differentiate u with respect to y. Will differentiate u with respect to z, and will differentiate u with respect to time. Understood? Understood? Now you see y component means what? V. Differentiate v with respect to x. Then differentiate v with respect to y. Then differentiate v with respect to z, and then differentiate v with respect to time. Similarly, z means what? W. So differentiate w with respect to x, then differentiate w with respect to y, then differentiate w with respect to z, then differentiate w with respect to time. Yes? Everyone understood this? Now see. Plus, plus, then what? U, V, W. Plus, U, V, W. plus 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 u v w. Everybody remember the equation or not? Tell me. Everybody now remember the equation, the convective part also and the temporal part also, right? The convective part also and the temporal part also. Everybody remember the equation, right? Everybody remember the equation. We derived it, we understood how we are writing the equation also. Very good, great, very good, great. So now, time to solve questions. Let us first solve some questions now. Okay. So the question is, okay, so this question was asked in GATE 2014. Okay. So you can see that x is this, y is this, and z is this. They're asking you the magnitude of acceleration of a particle in centimeter per second square at time t is equal to 0. You see, this is the parametric equation form. So I told you acceleration in x component, acceleration is what? I can use the first form of equation, that is what? Double derivative of x with respect to time. Then y will be what? Double derivative of your y with respect to time, or t. You are using time as the parameter, and then this. Can you find out the answer? Yes, learning new things today. Every day learning is more. Very good. So please tell me the answers. See, if we differentiate the first thing, it will be what? First we differentiate 3t square plus 2, then 6t. Yes, 6t. Second one will be what? It will be minus 6 and then minus 12 e to the power minus 2t. 2 times differentiation. Now I cannot teach you differentiation now. You have to learn differentiation. And then you see, when you differentiate this, first time sine 2, it will become minus cos, right? Or cos, only cos. Then again minus sine. Right? Sine 2 cos, then cos 2 minus sine. Right? So it will become what? First 2, but this 5 will come out, so become what? 10. And again when you differentiate, this 10 will become 50. So it becomes what? Minus 50 sine 5t. Very good. Now I'll put t is equal to 0. So t is equal to, this becomes 0. This becomes 0. Sine 0 is 0. And this becomes what? Minus 12. Ladies and gentlemen, this is the answer. They've asked the magnitude. That means what? The answer is equal to 12 centimeter per second square. You see, so fast you're able to solve questions if you have understood the basic concepts. Okay. You can easily find out the answers if you understood the basic concept. Let us solve the next question. Okay. This question was asked in GATE 2019, recent times. Okay, recent times. The velocity field in a flow system is given by v is equal to 2I plus x plus y and xyz. That means what? This is your u, this is your v, and this is your w. We are supposed to find out the acceleration of the fluid particle at 111. And suppose, I am not mentioning the answer here because options are given, but I don't want to mention the answer. Let us find out the answer in what? I cap, j cap, and k cap. Means what? I have to find out the x component, the y component, and the z component. I'll give you a small tip. First you find out u, v, w. First you find out u, v, w. So what is u here? U at this position will be how much, tell me? It will be 2 only because that's a constant. What will be v? V will be x plus, see, x is equal to 1, y is equal to 1, and z is equal to 2. So your v will also be 1 plus 1 is equal to 2, na? Yes. And w will be how much? 1 into 1 into 1, that is what? 2. So I can say at this position, at these coordinates, u, v, w is this. Very good. Now I told you how to write down the equation for ax, ay, and az. Now you see, this u, v, and w all are independent of time, na? This u, v, and w are all independent of time. That means local component will be 0, na? Yes. Del u by del t will be 0. Yes. Del v by del t will be 0. And then del w by del t will be 0. Okay. So I can say that the local component will be 0. So what will be remaining? The remaining will be what? Simply your convective part. So I told you how to write down the equation. Del u by del x, del u by del x, del u by del y, del u by del z. Similarly, del v by del x, del v by del y, then del v by del z. Understood? So see, this writing equation is the main, confusion. Yes, this writing equation is the main confusion, and by teaching you in this manner, your confusion is removed. Now it's nothing, you see. U, V, W, U, V, W. Yes, U, V, W. Anybody faced any difficulty in writing this equation? Anybody faced any difficulty in writing this equation? Anybody faced any difficulty in writing this equation? No, 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 no. Okay, now you see. See carefully. See, U is constant, na? U is constant, na? See, U is constant, na? Ramesh Mon also found an answer. U is constant, na? You see, U is constant. U is 2 only. It's constant. That means a differentiation with respect to X, with respect to Y, with respect to Z will all be 0. So the X component is 0 of acceleration. Now coming to your V. V is what? V is X plus Y. It is X plus Y. It means it's independent of Z. That means this will be 0, na? This will be 0. It's independent of Z. So now we can write down this as what? What you can write about A? I will remove this. I will remove this. This is done. This is done. So I can say that AX is 0. AX is 0. Now you see AY. What will be AY? What is the value of U? Value of U is 2. Now differentiate this V with respect to what? X. We'll get how much? 1. Na? Then the value of V is 2. Then differentiate this V with respect to Y. We get 1. So AY is 4. Na? AY is 4. Na? 10.77 right answer. Don't worry. We got this before 4. So AY we got. Now see, W is a function of X, Y, Z. So I have to differentiate. Right? So you see U, V, W all are what? 2 only. Value is 2. The value is 2 at this point. So I can take what? 2 as common. Then differentiate this W with respect to X. We'll get what? YZ. Then differentiate with respect to Y. We'll get what? XZ. Then differentiate this W with respect to Z. We'll get what? XY. Now we can put the values, right? Now we can put the values. So this becomes what? 2. YZ. YZ is 2. XZ is 2, XY is 1, we get how much? We get 10. So I can say the acceleration vector will be what? 0 I cap, then 4 j cap plus what? 10 k cap. So this is what? This is the vector. And if I ask you the magnitude, what is the magnitude? The magnitude will be root under x square plus ay square plus az square. That is what? 4 square plus 10 square giving me how much? As rightly found out by many people, 10.77. Hope everybody understood this question perfectly, yes? Now you see this question is looking very confusing if you have not remembered the equations, right? See, if you have not remembered the equation, this question looks so confusing now. You see, these equations become so confusing. But these equations are not confusing. Confusing are the teachers who taught you that. Yes, these equations are not confusing. These equations are telling I'm easy. I'm very easy. But you know, you learned from the wrong people and therefore these equations become tough. But if you have understood from a proper person, then it's very easy. Okay. Next. Okay, the next question is GATE 2019 again. Again 2019. Interesting. Acceleration of a particle, fluid particle at 1 at t is equal to 2 seconds. See, in the earlier question, the velocity was not a function of what? It was not a function of time, but here it is function of time. This is yes, it is for everything. It is for everything. Yes, it is for everything, okay? It is for everything, okay? Everywhere they ask the same question. See, fluid kinematics will not change if you are appearing for GATE or EAC. Means the fluid kinematics will tell, okay, now I am entering EAC, so let me change my things. No. Okay. Okay. So now you see this velocity vector, yes, it is only having j component. Means what? If this is the j component, can I say u is 0 and w is 0, right? U is 0, w is 0, and only I can say the, oh sorry, what happened? Okay, so I can say that y component is, that is what? 4 by t plus x plus y. Okay, now see. Again I have to write the equation, right? Again I have to write the equation. So can you write the equation, solve? I'll give you some time. Can you solve this? Can you solve this question? Can you solve this question? Okay, Bhavya has solved, but can you solve this question? Okay. But it will take some time. I'll write down the equation by that time. You try to solve, I will add the equation by that time. Plus, 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 plus. Then UVW, UVW, UVW. Now you see what has happened. And then we have that, when we have what? Then we have this also, right? The local component also. We have the local component over here. Okay. Very nice. Now you see many things will become 0. Many things will become 0. How? You see this U is what? U is 0. So this is 0, this is 0, this is 0, this is 0. Why? Because you see U is 0, so differential will be 0, right? U is 0, this is 0, this is 0, right? W is 0, this is 0, this is 0, right? And this is also 0, this is also 0. Yes, everything got cancelled. We can say that we only have the y component of acceleration. This will be what? V. Okay. So what is V value at this point? Tell me. What is the V value at this point? 1, 1 and 2. So 4 by 2 plus 1, 1. I am getting 4 na? Yes, it is 4 na? So 4 into, getting 4 or 3? Now tell me the value of this V. Tell me the value of V at this time and this the time and in this coordinate. This 4. Yes, it is 4. Okay. So V is 4. Sorry, V is 4. AY is not 4. So 4 into del V by del Y. What will be del V by del Y? It is 1 na? Del V by del Y is 1 na? You see, del V by del Y is 1. Yes. Plus del V by del T. Del V by del T will be 4 by T square only na? It will be minus 4 by T square na? X and Y becomes 0. Yes. Differentiate with respect to time only. Yes. And what is this value? What is this value at T is equal to 2 seconds? It is minus 1 na? So then minus 1, we get how much? 3 as the right answer. Understood everyone this particular question? You see, that means solving question from acceleration lies in just knowing how to use the equation properly, right? Yes, how to use the equation properly. If you know how to use the equation properly of acceleration, and easily solve the questions. Very good. Now, you see, this is a very interesting question. This was asked in, finally we came to IIT Kanpur. Okay, so IIT Kanpur is not our only destination. I can say this is our final destination for today's class. Yes, so we are solving so many questions, and then finally we are coming to what? IIT Kanpur, right? Finally coming to IIT Kanpur. So let us solve this question of IIT Kanpur. Okay, what is it done? We have a nozzle like this. Yes, nozzle like this. Yes, and I can say that the velocity is changing. Okay, in the beginning it is 1.5 meter per second. At the end we have what? 15 meter per second. And this distance is how much? It is 0.375. Okay, the velocity is changing here. Okay, the velocity is changing. Okay, and suppose if you are considering only one dimensional flow, then one dimensional flow, suppose in x direction. Okay, next direction. Okay, nothing is mentioned, so I can assume that that is the x direction. They are asking the convective acceleration. Okay, asking the convective acceleration. You see, since the flow is in x direction only, I can say what? V is 0 and W is 0, right? V is 0, V, W and 0, right? I can take them as 0, right? And consider this as what? Only U velocities. This velocity is what? Only the U velocities. If your V and W is 0 and it is not changing with time, they're asking only what? They're asking only the convective acceleration. So I can say we will be left with only the x component and the convective component of acceleration. That will be how much? That will be simply del u by del x na? Yes, u into del u by del x. Why not the other terms? Because it is convective. So we'll not take the local or temporal part, the time varying part, right? And then V is 0 and W is 0. So the next two terms become 0, right? The next term, next two terms become 0, right? Yes or no? Yes, become 0. Now this is what? This is U into del U by del X. Now you see U, they were asking what? At the end of nozzle. At the end of nozzle, U is this one, na? So 15. Now see, del U by del X means what? Change in the U with respect to change in X. You see, change in X is this one, na? 0.375 meter. So from here to here, from the beginning of the nozzle to the end of nozzle, the change in distance is 0.375. And change in the velocity is how much? 15 minus 1.5. Change in velocity is this and change in distance is this. Ladies and gentlemen, this is the answer. How much I'm getting? I'm getting an answer of 540 meter per second square. If the same question was asked at the beginning, can you give me what will be the convective acceleration at the beginning? Tell me. At the beginning, what will be the convective acceleration? Can anybody say me? They asked at the end of the nozzle. If they ask you at the beginning, what is the answer? No, there is no difference. I don't find any difference in preparation. I feel that if you're solving numericals, it's more or less same. Yes. And in theoretical questions also, they use the same logic. So please continue solving questions. So getting 54. Why? Because you see, this del U by del X will remain same, but U will change there. Now it will become 1.5. So answer is what? 54 meter per second square. So hope you enjoyed this today's lecture, which is not completed. I just told. Okay. So answer is 54. So we completed acceleration. Next we will go to where? In kinematics, next we will go to where? Tell me. Let me think. What topics I have chosen. We can find at any section. As Bhavya told, is asking, so not told, asking, if you want to find out at any section, what we will do? It is linear variation, na? So it is linear varying. Yes, we can just find out the linear variation, and then at that time, at that particular distance, suppose I'm asking here, you can find out the velocity, the U velocity, and then find out the this. Okay. So let us go to angular velocity and the rotational flow. A lot of questions are asked from there. Okay. Now what is your angular velocity vector? The angular velocity vector is half of the curl of your velocity vector. Now what is curl? Curl is what? Curl is the cross product of the del operator and the velocity. Yes, cross product. Now how we find out cross product? Very easy. This was what? This was d of dx of I cap plus d of dy of j cap. Remember this del operator? Initially I told, if you remember, when we are seeing the incompressible flow and all, I was taking a dot product. Here I will take what? The cross product. I'll take what? Cross product. Right? Cross product. So we take a cross product, see? And this is what? ui cap plus vj cap plus wk cap. So what I will do? I will take I cap, j cap, and then k cap. This is the way we find out cross product, right? And then d by dx, then d by dy, and d by dz, and then u, v, w. Yes. So now anytime you face any difficulty, just take the cross product. Anytime you face any difficulty in writing, sir, which one is what and all. Aditya, it is beneficial for ESC 2023 and GATE both. Yes, obviously. Because if you open your ESC questions, and no fight. Okay, don't fight, okay? So don't nobody fight here, okay? We all are very, okay, same question, but I'll answer this. Yes, it will be helpful for your ESC, okay? Please study, okay? Now, no fights. It might be a genuine query, so no fights, okay? Now let us come back to class. See. Now you know cross product, na? This is finding determinant, right? This is just finding the determinant, right? Just finding determinant. You remember determinant? If you don't remember, I will tell you. I cap, then what? Yes, w by del y minus del v by del z I cap. Understood? Plus or minus, minus. Remember determinate. Yes, minus this what? Minus means what? If I want to make it plus, what I will do? I will exchange the places, right? So become what? Becomes yes, and then k cap. Yes. So del v by del x minus del u by del y. Understood how we are finding this curl, half of curl? First I am finding curl and then I will tell you the angular velocity. Have you understood how we are finding this curl? Any doubt in finding the curl? See, I am here to make you remember, not only understand the equations, also to make you remember the equations, right? It is very important that you remember the equations also. Okay, so if you forget, you can always derive it. If you forget, you can always derive it. Understood? Yes. Now since it is half of curl, since the angular velocity is half of curl, so if you take a half of this, what will happen? All these components will become what? Half. So I can say this is the I component. That means what? Some issues, some problem I have done. Some mistake I have done. No, it's correct. No, it's correct. How to remember? I will tell. Don't worry. Don't worry. Don't worry. Don't worry. I will tell you. Don't worry. Okay. J part. How? It is minus j. Then what? dw by dx minus du by dz, na? And then if the minus sign is removed, I'll make it plus, then I will change the places. This becomes what? du by dz, and then this becomes what? Minus dw by dx. Now how to remember the equation I will tell. This is the original derivation I can say. Now see. So this I can say is what? This I can say is the x component of angular velocity. This becomes the y component and this becomes the z component. So I can say that now x component is what? Half, then what? See, you can always take this and find out. Still I will give you a tip. This is w by y minus v by your z, right? Hope you are also writing with me. Are you writing me with you or seeing the movie? See, these things you'll understand if you write with me. Are you all writing with me or not? Are you all writing with me or not? Are you all writing down with me? Then you will understand. Okay, write down with me. Don't only, don't only see. Write with me. Okay, now see. This is half. Yes. Don't worry, I will tell you. I will tell you everything. Yo. How to remember? How to remember this? See, write down x, y, z. And you will go in cyclic manner. You will go in what? Cyclic manner. Understood? Go in cyclic manner. So when I am writing x, cyclic manner, half will come. See the denominator. What should come? Y na? And then what should come? Z na. Understood this or not? Understood this or not? Tell me. Understood this or not? Cyclic manner? Cyclic manner, understood this or not? Yes. Now, we have Y and Z. Y component of velocity you will write here. And then Z component of velocity you will write here. Everybody remember the trick or not? Everybody remember the trick or not? Go in cyclic manner. X, Y, Z. So it is X, Y, Z. And then just interchange the components of velocity. Yes. Now you see. In similar way, I will write down Y also. You see. WY. So I will write down what? Half. Y means what? Go in cyclic manner. Z and then X. Yes. Then exchange their components. DU, DW. Easy. Next. WZ. Go in cyclic manner. Half. It is Z. After Z what is coming? X. And then after X what is coming? Y. Exchange the components. How many enjoyed this, whatever. Okay. So you see we derived it logically also. Yes. Yes. Here we derived it logically also. Means what is the actual derivation we did, right? We did the actual derivation. Along with that here, along with that we understood a short trick also. So both ways we understood, right? Both ways we understood. Now what type of questions they will ask, that is important. You see, when I say irrotational flow, means what? The angular velocity will be 0. Yes. Or I can say angular velocity is what? Half of curl of V, right? Curl of V. So I can say the curl of V is 0. Or I can say the cross product of del operator and V is 0. Yes. Now this is looking, all equation. If we see 2D flow, we'll only have what? Your x component of velocity and y component of velocity. In that case, I can say the angular velocity will be only existing in what? In your z direction, and I can say that will be half x and y. Z, x, y, cyclic. Exchange the components, dv, du. Right? And this will be 0 if it is a irrotational flow. And I can say in that case, this will be equal to this. Understood in irrotational flow how this condition came? Okay. If you are forgetting the equation, then always you can write it down. And I gave you the trick also. Right? And it became 0, so this becomes 0. So instead of remembering this, if you remember that, the 2D flow, this will be 0, and you know how to write down the equation, then you can easily find out. Understood? So we understood steady flow, we understood irrotational flow, we understood incompressible flow. So let us solve some questions. Okay. So IIT Kanpur came first. Hello IIT Kanpur. Okay. So IIT Kanpur came. Welcome to IIT Kanpur 2015. Please solve this question. U component is given, V component is given. Please tell me which is the right answer. Fluid is incompressible, irrotational. Now you see all these questions were looking so difficult. You used to run away from these questions. When you used to see these questions, you used to shout like this. Ah! Yes. But now when you are seeing the questions, you are looking forward to solve them. Right? When you are seeing these questions, you are looking forward to solve them. And you should learn from a teacher where you are looking forward to solve the questions. If you are seeing the questions and you are becoming frightened, that means there is problem with you and also your teacher also. Now tell me. Tell the answer. What is this incompressible? Tell me the answer. What is the answer? Tell me. What is the option? Which option is correct? Tell me. Which option is correct? Tell na. So many things are writing A. Ahmedabad. Okay. From IIT Kanpur to Ahmedabad. Very good. You see, you were able to solve in less than 1 minute. Na? You were able to solve in less than 1 minute. Na? Yes. Let me just see minus x squared 2. And then what is V? V you are getting xy square minus 2y plus x cube by 3 or minus x cube by 3. Okay, so this is the equation. So first thing is incompressible. So in that case, what we will check? Du by dx, the continuity equation, right? The continuity equation I will check. Is it 0 or not? Let me check. So if I differentiating with respect to x, 0 plus 2 minus 2xy. And then with respect to y, it will be 2xy minus 2 and then 0. So yes, it is 0. That means it is incompressible. Yes, it is incompressible, right? Now coming to your this. So this is 0. If you have forgotten the formula, half x, y, exchange the velocities. This equal to 0. I mean this has to be equal to this. So dv by dx. If I differentiate with respect to x, the v will get y square and then I will get how much? X square, right? Yes. This is this. Now what is this? With respect to y, this will be y square and then x square. Yes, these two are equal, right? These two are equal, right? That means what? It is irrotational, right? It is irrotational. You're getting equal value. So this is irrotational and this is incompressible. So flow is incompressible and irrotational. Beautiful. So let us go to 2015 again. IIT Kanpur repeats in another set. Okay. One question they ask in civil, one question they ask in mechanical. Fluid kinematics will not change if you are studying civil or mechanical. The IIT Kanpur is asking, or IIT Kharagpur is asking, or IISc Bangalore is asking, fluid kinematics will remain same. It is GATE, it is ESC prelims, it is ESC mains. Fluid kinematics don't change. The theory will not change. The theory will not tell, I am being asked in IIT Kanpur, so I will have some different value. No. So please solve this question. 2D flow. Please solve this and tell me the answer. Delhi. Delhi, very good. You see, same thing. U, V. You can do some by seeing also. Du by dx is how much? Is 1 actually, and dv by dy is minus 1. So this is what? This is, I can say, is, you're getting 0, na? So it is incompressible, na? Yes, it is incompressible. It is incompressible, yes. The next thing we have to check is it is rotational or not, right? So I'll differentiate this u with respect to y, I will get a 2, and v with respect to x, I'll get, they're not same, right? We'll get 0. So I can say that du by dy, okay, is not equal to your dv by dx. So it is rotational. It is rotational. Rotational means what? Not irrotational. So answer is D. Thank you very much. Okay. Okay, 1993. Surely many of you are not born. Sure, I can bet that 99% of you are not born in 1993. I was born. I am very old. Not that old, but old enough to be born in 1993. Uncle log calling me uncle. Calling me uncle. Okay, good. Come on, tell me what is the right answer for this? Which of the following options are correct? Multiple select question. Multiple select question. Which of the following options are correct? Only A. What about C? What about C? Multiple select question, sorry. Or multiple correct question, same thing. What about C? Yes. It is an incompressible flow because you see this is U, this is V. This is U, this is W, right? Okay, this is V and W. So if we are representing dV by dy, continuity equation dW by dz, that will be how much? V is how much? Difference with respect to this is 3x square. Okay. Oh, this is I cap. Now this is U. Sorry, U. Sorry. U. Sorry. So with respect to x, then it will be 6xy, and respect to z, it is 6xy. So getting cancelled. Yes, this is a incompressible flow. You see, it is not a function. Velocity is not a function of time. Steady flow. Velocity is not a function of time. Steady flow. Rotational thing. You see, we have U component and W component. That means what? We will go for your which one? Which angular velocity will go for? We'll go for which angular velocity? Y. This will be equal to, I can say, half of Z and then your Y. Sorry, X. No, sorry, X. So this will be du and dw. So this is how much? With respect to Z, 0. And with respect to X, it is not 0. Certainly it is not 0. It is minus 6yz. So these two are not equal. That means what? Angular velocity is not equal to Z. It is rotational. So this is not the right answer. Understood? Agra to coaching. Very good. Okay. GATE 2015. Finally, IIT Kanpur arrives. Okay, so IIT Kanpur, please welcome to the show. Yes, so. Now, this is something known as total derivative. This is known as what? Total derivative. Okay. Total derivative. What is total derivative? Total derivative is this. You see, when you are finding our acceleration, okay, it is the, suppose x direction, that is what? Your convective component and the local component. Both are there, na? So, if you are doing, this, when you are writing this, you are doing what? Ax is equal to, actually writing du by dt, that du by dt is total derivative. This is what? The total derivative. The difference with respect to your space also, respect to your time also. Okay. Now see this. This is the match the following. This is match the following. You see, this indicates what? This indicates what? Tell me. I have explained already. Hi, good night, sir. Thank you. What this indicates? Hey, what this indicates? Huh? What this indicates? Tell me what this indicates. Tell me. Curl is 0. Curl is 0 means what? Your irrotational flow. This is what? Irrotational flow. So this is your irrotational flow. Now see, this is what? The dot product is 0. And this is what? This is what? This is your incompressible continuity equation, right? Right? And when I say dV by dt is 0, means what? It is not, it's a partial derivative. It's a partial derivative. Means what? It is independent of time, but it can be what? It can be dependent on what? Space. Independent of time means what? Steady. And then total derivative 0 means what? It is independent, total derivative 0 means what? Accelerations, local component is 0 and convective component is 0 means what? 0 acceleration of fluid particle. Understood? So I can say P for 3, Q goes to 1, R goes to 4, and S goes to 2. So you see, this was a very, how it is NIT Warangal for masters. It's good if you are interested in research. Next. Okay, next we'll study something. What we'll study? So the angular velocity and then all this stuff got finished. Let us go to next thing. Which next thing you want to make me teach you? Let me see the list of topics. I have summarized a list of topics also so that I don't miss any topics. Okay. Phi and your psi function. How many get confused in these two functions? How boundary layer will not go first. Let us complete our fluid kinematics. Let us first complete fluid kinematics. How many get confused in these two? Phi function and psi function. Okay, phi function and psi function. How many get confused? Many get confused. Both are scalar functions. Both are scalar functions, and they are used to find out what? Your velocity. Now see, if you differentiate phi with respect to x, you will get what? Minus u. If you differentiate this phi with respect to y, you will get what? Minus v. It is very easy. It is very easy. You see, you are differentiating with respect to x, you are getting a negative of the component of velocity in that direction, right? You are differentiating with respect to y, you are getting a negative of the component of velocity in that direction. Understood? Understood? Very good. Now, how to remember this psi function? Very easy. X, y. So, if you differentiate this psi with respect to x, okay, then what you do? This is x. This is x. You go 90 degree from x. You go 90 degree, turn 90 degree from x. What you are getting? You are getting y na. So you'll get the velocity component in y direction. Yes. Now you see this. With respect to y. When I'm differentiating with respect to y, what I will do? From y, I will go 90 degree clockwise. See. When I am differentiating with respect to x, I am going 90 degree clockwise. So I am arriving where? Y. So I got the velocity in y direction. Now see, from y, if I go 90 degree clockwise direction, where I will arrive? Where I will arrive? Tell me. Where I am arriving if I am going from y 90 degree? Where I am arriving? Where I am arriving? Tell me. Yes. सर आप कितने बजे तक पढ़ाते हैं जब तक बोर नहीं हो जाता? Minus x. Okay, minus x. Minus x means what? I will get the minus of the velocity. Okay, okay, very good. Understood everyone? Understood? Now anybody will get confused. Psi function and phi function. Velocity potential function and your stream function. Okay, stream function. See, again I will tell you. Again I erase this. Tell me, now you will tell me what I will get. Tell me. What I will get, tell me. What I will get, tell me. Phi function. Yes, very good. Minus u. What I will get, tell me. Yes, very good. Now tell me. Tell me. ये मुकुल गलती कर दिया. Wrong. See. When you are finding for psi, you are in y, differentiating with respect to y. Go 90 degree clockwise. Where you are arriving? Minus x. So minus u. Right? And then this psi by x. This is how much? Tell me. Now tell me, this will be how much? This will be how much? Yeah, very good. Yes. So remembering these equations are very easy. Let us solve one question. Where is the question? Oh question, where are you? Question went where? Question just went somewhere. Question became, question just ran away. Hey, Lingaraj Pradhan is missing me. Hey, if you are missing me, then attend the classes now. If you are missing me, please come and attend the classes. If sign convention is different, no. This is what we will use in the numericals. Okay, don't miss. Why b is not minus? See, this is the trick I am giving you. I cannot derive now. Okay, derivation, everything I have done. Okay, derivation, everything I have done. You visit the BYJU'S exam prep. There I have taken the detailed lecture. Here we are summarizing and solving questions, so I will not derive it. This I am giving a trick to remember the equations. Now see, I am telling that the potential function is 5x square minus y square. Okay, so give me the velocity vector at 4, 5. Give me the velocity vector at coordinate 4, 5. Can you give me the velocity vector at coordinate 4, 5? Please give me the vector. Means I cap, j cap, k cap. I am also BYJU'S faculty only. Obviously. Minus 40 I cap plus 50 j cap. Okay, very good. Okay. So now you see, this is t psi by the 5 phi, this is equal to minus u. And this will be u is equal to minus 1, minus s. And I can say your v will be what? Minus this. Okay. See, you have to derive it now. I can't derive now. I don't want to derive here, okay? You don't want to waste time. Some other day we can derive it, okay? Okay, very nice. So here you will be what? Differentiate with respect to x. Will get what? 10x, na? Minus 10x. So getting how much? Minus 40. And then v will be how much? Minus 10y. That is what? How? Oh, this is actually will get minus, get a plus. So it gets 50. So minus 40 I cap plus 50 j cap. Now, a very typical type of question which they ask in the examination. Okay, the phi function will be given. We have to find out what? The psi function. Okay, the phi function is given. You have to find out the psi function. See, Ramesh Mon, see, try to understand. We have limited time. In limited time, I am trying to give you the maximum things. Okay, if I start deriving now and explaining so many things, it will take half an hour more. So we don't have time. Okay, some other day. To find the psi function. Okay, let us see how to find out this. This is a very typical type of question. Now IIT Kanpur has not asked, doesn't mean that they will not ask this time. Okay, you see. Now you see what will be d phi by dx. How much I am getting here? It will be 2y minus 1, right? It will be 2y minus 1, right? 2y minus 1. And this is actually what? This is actually minus of u, right? It's actually minus of u. Now minus of u is del psi by del y, na? Okay, you're not telling, so I will tell. Now next thing is del phi by del y. Yes. Now this is how much you are getting. You're getting this if I expand the bracket 2xy minus x. So del phi by del y. That how much? You will get your 2x, na? You will get 2x. Yes. And this is your minus v. Yes, I can say v is equal to minus 2x. And this will be what? This will be your del psi by del x. Yes, understood? So del psi by del y, I got this, means that is equal to how much? 2y minus 1, and this I get minus 2x, right? Now if I integrate it, so psi will come how much? If I integrate, I'll get 2y square, then 2y square by 2, so y square minus y. I'm integrating with respect to x, so a function of x. And here I'll integrate with respect to your x, so it will be minus x square, yes, plus a function of y. Now you see these two things, what you're getting? You're getting psi function is equal to y square minus y, then function of x is what? Your minus x square. And then here this f function is what? This one. Understood this, everybody? Everybody? So if they ask a question like this, okay, then you can easily solve. Now there are many other things like equation of streamline function, yes, phi function streamline function, yes, equation of streamline function, then equation of equipotential line means what? Your phi function, okay, all those things, okay, so we can't do here, okay. So this I tried to solve many of the questions and solve many of the questions, and what I tried is that we complete fluid mechanics, we fluid kinematics, right? So now I had two options. I had options of only solving the previous year question. There were 5-6 previous year questions of kinematics, and there were some 6-7 previous year questions of dynamics, and there were some 2-3 questions of boundary layer, and there are some 4-5 questions from your hydraulic machines. Okay. Now when I saw the questions, I understood that if I solve only these 6-7 questions of dynamics, or 2-3 questions of boundary layer, and 4-5 questions of your machines, then you will not get the complete idea. You see, today we solved many questions of kinematics. How many were there from IIT Kanpur? Hardly 4, 5, 6, 7, right? Hardly 5-6 questions were from IIT Kanpur, na? Yes. 5-6 questions were from IIT Kanpur, na? Yes. The rest were from some other IITs, right? From other years. Now tell me, if I would have solved only the 5-6 questions of IIT Kanpur, will that be any beneficial for you if I am talking about fluid kinematics? If I only have solved the 5-6 questions of IIT Kanpur, then tell me, will you get benefited? No, right? You will not get benefited. Okay. So therefore, what I decided that I didn't tell you in the starting, otherwise would have run away, ran away. So today my plan was that I will teach you kinematics in not in I can say everything, but I can say that I completed 80% of the important questions which are asked in your fluid kinematics, and 20% obviously I have not solved. Okay. So everything I cannot cover. So I will plan to take dynamics and boundary layer theory, okay, and some other day I will try to take, okay. So tomorrow we cannot take because there is some other session planned, but GATE exam is not tomorrow, right? So some other day I will teach you what? Boundary layer theory, okay. I will not solve only previous year question. I will take a session, I will plan soon in this month only, okay. I'll try to take up boundary layer theory where I will not solve only questions, I'll explain you the boundary layer theory, okay. So hope you enjoyed today's session. And tell me, how many of you got confidence? How many of you got confidence in solving questions of fluid kinematics? Tell me, how many of you got confidence in solving questions of fluid kinematics? Yes? Many students got confidence that that how to solve the questions of fluid kinematics. So we'll come up with more sessions, okay? We'll come up with some more sessions, okay? It's not the end. Tomorrow, I think, for mechanical students, I think there is production engineering, I think, scheduled. Let me just check the schedule. Yes. For mechanical engineers, okay. No, there is theory of machines scheduled, okay. So tomorrow theory of machines is there, okay. And so tomorrow theory of machines is there. So all the students of mechanical students, they can attend theory of machines, okay. And then for civil students, I will be teaching you irrigation, okay. I will be taking irrigation lectures for civil students, okay. And theory of machines will be taken by Sadhana sir, this is Sadhana sir, okay. So he will take tome, I think time is 10:45 only, okay. So 10:45 tomorrow, civil students, irrigation engineering, I will not only solve IIT Kanpur questions, I will solve everything. Okay, like this. Okay, you can see Mr. Amir, you can visit you. See, I am seeing from the official YouTube channel. Okay, so if you go to the official YouTube channel and you can click on what? Future upcoming classes. So there you know the schedule will be there. Okay, the schedule will be there. Okay, so once check the schedule. And another thing you can do. See, if you see in this lecture, okay, if you see this lecture, there will be what? Telegram groups are there. You see, there are Telegram groups. You see, Telegram groups are there. So if you join the Telegram group, there the schedule will come. Okay, if you join the Telegram groups, there the schedule will come. That will be helpful to you if you are planning to attend the future lectures. Okay, so in the link below, is the Telegram group visible? Let me see. Yes, there are some. Yes, Telegram groups are there. You see, there is mechanical Telegram group. Okay, there is EC. Okay, all these things are there. So, okay, so once you visit the Telegram group, there you will get all the notifications. Okay, thank you very much. Okay, this is not the end of fluid mechanics. I will again come back some other day to teach you some other good things. Thank you very much. See you tomorrow, 10:45. Civil students, irrigation engineering.